off fan. Hey everyone, welcome to another live streaming. We are going to continue our discussion on Codeforces Round 1065, Div 3. Last session we did till question number 1, which is question A. Today we will pick where we left last time. So we'll be starting at question number B, and we'll go from there. So I'm going to go through these questions one by one. Right now, everyone, please with uh, get ready with your computer. Open up the challenge, and we'll get started. The link to the challenge is I'm sharing the link to the challenge in the chat, or I'll add the challenge link in the description. You can get the challenge link from the description. 1065, and I'll start from question number B. If you have missed question number A, don't worry too much about it. It was anyway a very easy question. There was nothing too complicated about it. You will I mean, if you have missed that question, don't worry about it. Get started with question number B. So first, I'll explain question number B. It's U Koito minimum absolute sum. So let me write it here. This is CF, this is CF 1065 div 3. 1065 div 3. This is question number B, which is U keto Koito, U Koito, and minimum absolute sum. Let me read out the question and then I'll explain the question. This is the title, this is the challenge. Open up this challenge, open up this question, and I'm gonna read the question. U is trying out the student council. Unfortunately, she has been forced to do clerical work. Tokyo wants her to fill out the blanks in various student council documents. You are given a partially filled array of non-negative integers a1, a2 till an, where blank elements are denoted with -1. You would like to fill in the blank elements with non-negative integers such that the absolute value of the sum of elements in its difference array is minimized. You would like to fill out the blank elements with non-negative integers such that the absolute value of the sum of elements in its difference array is minimized. More formally, let B be the array of n minus 1 of length n minus 1 such that Bi is equal to Ai plus 1 minus Ai for I in range 1 to n minus 1. Find the minimum possible value of B1 plus B2 plus B across all possible ways to fill the blank elements of A. Additionally, output the array that achieves this minimum. There are multiple such array. Output the one that is lexicographically smallest. The first line contains a single integer t, the number of test cases. This first line of each test case contains a single integer n. The second line of each test case contains n integers between -1 to 10 to the power 6. It is guarantees that The sum of n overall test cases does not exceed 2 to the 2 into 10 to the power 5. For each test case on the first line, output the minimum possible value of b1 plus b2 plus till bn minus 1. Then on the second line, output n integers, values a1, a2, an in lexicographically smallest array, achieving this minimum. Okay, so I'm going to explain the question. There are few givens in this. First thing that is given to you is an array A, which has A1, A2, A3 till AN. This array is given to you with A1, A2, A3 till AN. Now the thing about this array is AI is between -1 to 10 to the power 6. You know that AI is between -1 to 10 to the power 6. The second thing that is given to you is if AI is actually equal to -1, that means AI is blank and can be replaced. Actually, instead of saying can be replaced, I should say AI is blank and has to be replaced. AI is blank and has to be replaced. So you are given an array A1 to AN. If AI is -1, AI is blank and has to be replaced. Now what happens next? This AI is given to you. What you want to do is to do fix values of AIs where AI is equal to -1. Fix values of AI where AI is equal to -1 such that sigma bi is minimum, where bi is equal to ai plus 1 minus ai for all I 1 2 and -1. So fix values of ai where ai is -1 such that the bi is minimized where bi is equal to ai plus 1 minus 1, ai from 1 to n minus 1. You have to output bi, output sigma bi, output sigma bi. Oh, actually, this is outside. This is outside. Output sigma bi, output sigma bi. And then what do you want to do? This is first output and second A. after updates. A after updates. That's the breakdown of the question. We started with an array. We decided for every value of -1, you have to insert something, and such that the sum of differences of consecutive elements is minimized, the absolute sum of differences, not the sum of absolutes, but absolute sum of differences is minimized, and you have to output the absolute sum of differences and the A after updates. That's the question. Now, how do we break it down? How do we deal with it? Try to spend some time writing this down, and try to spend some time writing this down. Let me move this side. Wait a second. Let me move this side. This is good. Let me stand here. This is good. But how will I move? Yeah, I think I can. This is bad. Okay. Anyways, so this is better. I stand here and I go there. The only thing is with the mic, I have to do something. Let me see what I can do. Maybe I can. Oh, yes, I think I know what. I can put the mic like this. And now if I go here, there is no problem. And I come here back this way and this way. Good. Yeah. Just give me 1 minute. Oh, I can pull this and put it here. Think about the question for a few minutes. Yeah. Day after tomorrow, I'll get the mic. I'll get a better mic, and then these problems will not come, and it will be much smoother than. But for the time being, just to stay with this setup. So that's the question. Now think about the solution. The limits on n. The only limit that you need to know is limits on n is n is going to be greater than 2 and less than 2 times 10 to the power 5. So what you're typically looking for in this case, if this is the time, if this is the limits, what you're looking for is a time complexity of somewhere o to the power o n. Even o n log n will work in this case. Both of these time complexities are fine. That's the question. I hope you can take a screenshot of this at this point, because I'm gonna rub this and we'll move on to. I mean, I'll wait here for a few minutes for you to take notes, and then I'm gonna rub it. I'll move it slightly more. Yeah, this is good. This is good. I'm gonna let it be here for a few minutes, and then we'll move on to the solution. So let's discuss how this pans out. I'm not going to remove. Uh, Let me see if I can write a simpler version of this. This was the whole question. Now let me write a simpler version. Here is the one line problem. Given array A with empty elements, fill empty elements to minimize mod sigma I is equal to 1 to n minus 1 a I plus 1. Just give me 1 second. Let me rub this. Given an array A with empty values, minimize a I plus 1 minus ai. That's the question in one line. That's the question. Think about it for a few minutes. One thing I want you to do at this point is open up this expression here. The expression written here, try to open it up into a extended format. What will that look like? Let's call this expression as b. Then b is actually equal to sigma a2 minus a1 plus, oh sorry, absolute value of a2 minus a1 plus a3 minus a2 plus a4 minus a3 plus dot 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 an minus an minus 1 mod. That's the expression b. Do you see something interesting in this expression? Notice this expression here, this one here, and this one here, and this one here. This a2 is plus here and minus here. This a3 is plus here, minus here. So if I simplify this expression down, what I will get is this a2 will cross this a2, this a3 will cross this a3, and what I'll get, this a4 will be crossed by something here, and this an minus 1 will also be crossed. What I'll get in the end is mod an minus a1. That's the expression that you get. Once you have this expression, problems become very simple. Problem solution. Solution is just this. If an is equal to -1, you do an is equal to a1. L if L if a1 is equal to -1, you do a1 is equal to an. You make them equal, so the difference is 0. If these two conditions are not there, then I mean, if they are not there, then let a1 and a2 be the same, and then you do for I in 1 to n, sorry, not 1 to n, for I in, just set the last and the first value, and for I in 2 to n minus 1, what you do is ai set all these values equal to 0, because you want lexicographically smallest number, and then you just return, and then you just do print an minus a1, print a. That's it. That's the whole solution for this problem. First you check if the current element, if the last element is -1, then set it equal to first element. If the first element is -1, set it equal to the last element. Other than that, for I in range 2 to n minus 1, set if uh, for I in range 2 to n minus 1, ai is equal to 0 if ai is equal to -1, else ai. So if it is -1, then set it equal to 0, and then rest of the code remains the same. So that's the overall solution for this problem. So we are at, just give me 1 second, 235, 2240. See. Let's move on to the next problem. And if you have internalized this question, well and good. Let's move on to the next problem. I'm gonna rub this board. So if you have not taken a screenshot, take a screenshot now. And I'm rubbing the board now. Let's move on to question number C. This was, so C has two parts, C1 and C2. First part is easy, second part is difficult. It is Renako, Amaori, and Zor game. So I'll discuss both the parts one by one. C1, Renako, and Renako Amori. Renako Amori and Zor game. So this is C1, which means it's the easy version. I'm gonna draw a line below this. At this point, I want you to go to the question and read it out before we move on to something else. I'm gonna read the question out. Yup, I couldn't do this any longer. No freaking way. This is the easy version of the problem. The only difference between easy and hard version is that in easy version, AI and BI are less than or equal to 1. Renako is stuck between a rock and a hard place. And by that, of course, I mean Jesse and Mai. Both of them want to hang out with her. Both of them want to hang out with her. And she just cannot decide. So Ajay C and Mai has decided to play the Zor game. So it's a love triangle. There's this one person want to spend time and two people want to spend time with them. So they to decide who should spend time with Renako, they have decided to play a game. Let's understand what this game is about. Ajay C and Mai are given two arrays A and B, each of length n. They'll play a game that lasts for n turns, where Ajay C moves on odd number turns and Mai moves on even number turns. On ith turn, the player to move may choose to swap AI and BI or pass. Note, note that if a occurs, the index that is being swapped must match the turn number. For example, on the first turn, a Jaisi may swap A1 and B1 or pass. On the second turn, Mai may choose to swap A2 and B2 or pass. This continues for n terms. Thus, only a Jaisi can swap odd indices and Mai can swap even indices. At the end of the game, Ajaisi achieves a score of A1 Zor A2 till Zor AN, and Mai achieves a score of B1 Zor B2 till BN. The player with highest score wins. If the players have same score, the game ends in tie. Determine the outcome of the game with optimal play. More formally, one player is considered to win with optimal play if there exists a strategy for them that they always win, regardless of their opponent's choices. The game is considered a tie with optimal play. The game is considered a tie with optimal play if neither player has such a strategy. So I'm gonna write the ideas in the question on the whiteboard because there are many ideas in this question. What is given to you? Given, you are given two arrays, A, which has, I don't have to write that, given arrays A and B. What is the range of numbers? For this easy version, both AI is 0 to 1 and BI is 0 to 1. So to simplify this, what it means is, given two binary arrays, given two binary arrays, given two binary arrays, player 1, player 1 can player 1 can swap AI and BI. Player 1 can swap AI and BI if I mod 2 is 1. Don't worry about, I would say, first thing you have to recognize in this question is not to worry about the sequence of the play. What is important is all the values where I mod 2 is 1, player 1 can swap them. And player 2 can swap AI, AI and BI if I mod 2 is equal to 2. Given two arrays, this is the play condition. Let me make this 0 bigger. This is the play condition, and then what it says is the score of player 1 is equal to score of player 1 is equal to A1 XOR A2 XOR till XOR AN, and score of player 2 is equal to B1 XOR B2 XOR Bn. That's the score. Uh, Output, I would say no. I'll have a win condition as well, so that so this is the score. These two conditions are together. This two is together. This is one, and finally, player with higher score wins. Player with higher score wins. Output, what is the output? Winner if both play optimally. If both of them play optimally, who will be the winner? That's the question. A tie if scores are equal. Tie if scores are equal and a player with higher score wins. Winner if both players play optimally. The limits, there is only one limit you need to know, which is n. Here n, I'll write a small n. Here n, which is the length of A and B, n is less than 2 into 10 to the power 5. What it means is you are again looking for an solution in On or O n log n. That's the question. Take some time to either take a screenshot or note down the question, and I will move on. Let me put this in. Let me put a line here, and let me put a bracket here. Yeah. So that's the question. Think about it. How you will solve it. Give it some time. Yeah. So this was the question. Now let's go over some examples to understand how who will win in each of these examples. I'm going to rub this. I'm trying to figure out a easy way to write this. Let me rub this and see if I can. Uh, so here is the question in simpler terms. Given two binary arrays A and B and two players where player 1 can swap AI and BI on odd odd indexes, where player 1 can swap AI and BI on odd indexes and wants to maximize maximize XOR of A and player 2 can swap AI and BI on even indexes and wants to wants to maximize or XOR of B output, who will win? That is the question. It is not one line, but it's a single statement covered in three lines. That's the question. Let's do some examples to understand. I'll start with a simple example. The first example is one. This is A and this is B. One. I'll draw some lines here. If A is 0, 1, These are all. I'll do five examples. I'll do four examples. So first example is A is 1 and B is 0. Guess who will win here? Player 1 can swap these two values. So this is player 1. Player 1 can make B as 1 and A as 0. If player 1 makes his move, then if player 1 decides to swap, then A will become 0, B will become 1, and XOR of A will be 0, XOR of B will be 1. So ideally they will not decide to swap. If they do not swap, A will be 1, B will be 0, and XOR of A will be 1, XOR of B will be 0. So they will win here. If either one of these conditions allow them to win, they are going to win, in which case we will say player 1 is the winner. Player 1 wins. Now let's do another experiment. If both A and B are 0, then no matter what player 1 does, this is one example, but you can build another example, which is A is equal to 0 and B is equal to 1. In both of these examples, player 1 is going to win because they can decide either to swap or not to swap, and depending on the values of A and B, they will win. One example where A is 0 and B is 0, no matter what the player 1 does, there is going to be a tie. There is another example of tie that I can build, which looks like this: A 0 0, B 0 0. There also, if A and B are equal, there is no no, this is also a tie. Let me build another example of tie. Let me just try to build some examples of ties. So another example of tie is 0 1 and 0 1. Here it is going to be a tie because there are few scenarios. This is player 1 and this is player 2. Now if player 1 decides to swap, then this will become A as 1 0 and B as 0 1, and their XOR will, both of their XORs will be 1. Or if player 1 decides to swap and player 2 also decides to swap, so player 1 swapped, this happened. If player 2 decides to swap, then A will become 1 1 and B will become 0 0. In either case, no matter what player 2 do, no matter what player 1 and player 2 does, it is always going to be the same. The XOR of A will be equal to the XOR of B. So there is no, this is always going to break in tie. Another example of this is A uh, 0 1, B 0 1 0 1 0 1. This is also an example of tie, or I can move these two up also. No matter what you do, you can satisfy yourself in these questions. No matter what you do, you're always going to end up in a tie. Sorry, this is not this. You are always going to end up in a tie in these questions. I'll give you a question where it will not end up in a tie, and I will ask you to figure out who is the person that will win here. Let's say I have this. Let's say this is the example I have. Who is going to win in this case? We have seen these are the tie examples. This is where player 1 wins. What will happen here? Can you can you do something to club these two examples? I would say this example here and probably this example here, or yeah, or maybe this example here, this example and this example, to give answer for this example. You have a as 1 1, b as 0, a b as same, and this. So the way to look at it is, for these two values here, no matter what a player 1 and player 2 does, the XOR of a and XOR of b will be same till this point. Okay. So XOR of a, if XOR of a is 1, XOR of b will be 1. If XOR of a is 0, XOR of b is 0. So the player that commands this node P1 in this case is going to win. So this is the winner, P1. No matter what you do, the if so there are four cases. XOR of a till 2. If XOR of a till 2 is 1, okay, I'll draw all the cases. There are few cases that can happen when player 1's term comes. So you can have a as 1 0, b as 0 1. In this case, both of them are 1. So player 1 can decide to play his game and make b as 0 and a as 1. Okay. Or this can be like this: a can be 1 1 and b can be 0 0, in which case both of them are 0. Player 1 may decide not to play the game and make a as 1. So in both the cases, player 1 has a clear strategy. Can you identify what player 1 has that player 2 does not have in this case? The key thing that player 1 has is the capturing of the last node that matters. The player that captures, the player that owns the last node that matters is going to win in the case where there is a clear winner. If there is no clear winner, like in this case, it does not matter. Like this case, it does not matter. But when there is a clear winner, and how do you determine who is the clear winner? So if you look at this, now I'm going to make some observations. If you have not taken down the notes here, please take it now. I'm going to rub this. Oh yes, I generally don't. Oh yes. Let's make some observations. First observation I have for you is that XOR of A is either going to be 0 or 1. XOR of B will also be going to be either 0 or 1. XOR of A and B are going to be 0 or 1. And XOR of A, XOR, XOR of B is going to be constant. What that means is the XOR of all elements all 2n elements, if you take the XOR, because elements are not changing, you are just swapping them, it is going to be constant. Let's call this total XOR, or I'll call it XOR of AB. Uh, XOR of AB. When I write AB, it means A concatenated with B. XOR of AB. Now what will happen? XOR of AB can also be either 0 or 1. If XOR of AB, if XOR of AB is equal to 0, then it has to be a tie. That's my claim. The reason for this is, if XOR of AB is not going to be changing, then if A becomes 1, then B will also become 1. If A becomes 0, then B has to be 0. So these two are coupled if this is 0. So it has to lead to tie. And if XOR of AB is equal to 1, if XOR of AB is equal to 1, the claim is player owning the last different player owning the last different position will win. The player who owns the last different position will win. So it does not matter if this is, let's say, A and B or something like this, 1 1 1 0 0 0, then player 1 is going to win because this is different. And let's say there is 1 1 here, although player 2 has a position after this position, but since this is the same position, no matter what player 2 does, it is not going to change the answer. So this is the last position with difference. This is the last position with difference. Whosoever owns this is going to win. And that's the overall breakdown of this question. Now I'm going to write the code for this. I'm going to write a pseudo code for this. I'll not use any language. Okay. So solution. This takes two arrays A and B, and it takes n, which is the length of the arrays. Then what I'm going to do is, first I'm going to say, if XOR of A concatenated with B is 0, return tie. Say tie if it is equal. For I in 1 to n, If AI not equal to BI, winner equal to player 1 if I mod 2 is equal to 0, sorry, is equal to 1, else player 2 else player 2 return winner. This has to happen. It has to be at least at one place they have to be different if this is not equal to 0. Otherwise, if it is equal to 0, uh, if it is equal to 0, you always return tie. So that's the overall code. It's very simple, but it is mathematically challenging. So just get used to this level of difficulty. Now, this is question number 1. Now I'm going to go to the harder version of this question. So if you have not taken the notes, please take them now, and we will move on to the harder version of this question. Did you do this? Hard version. Let me read out the problem. This is the hard version of the problem. The only difference between the easy and the hard version is that in the hard version, the elements in array A and B can be as large as 1 million. So I'm going to write the question again in the simpler format. I'm going to write the short form of the question because I've explained the question. Given now I'm going to say given two arrays A and B, given two arrays A and B, and two players, player 1 can swap AI and BI if I is odd and wants to maximize XOR of A, player 2 can swap AI and BI if I is even and wants to maximize XOR of B, output the winner in optimal play. Output the winner in optimal play. Uh, turns turns happen from I is equal to 0 to I is equal to n. So sorry, not I is equal to 0. I is equal to 1 to I is equal to n. So you go from left to right and try to maximize the array. Yeah. Think about this. How does this change? The only thing typically I've changed is this AI and BI can have integers till 1 million instead of having just 0 and 1. See, so basically think of it like this. Instead of having one single bit, they have around 10 bits, 20 bits. They now have 20 bits, and you have to decide how to choose the optimal, I mean, how to decide the winner if there are 20 bits instead of one bit. This should not be a difficult question if you have truly understood the easy version. So now AI, let's not move to 20 bits for the time being. Let's move to 2 bit integers. So let's say AI and BI. AI is in the range 0, 1, 2, and 3. BI, let's just have two bits integers, 1, 0, 1, 2, and 3. Let's extend that solution to 4 bits. So then let's have some examples of A and B. I'm going to write these numbers as their binary representations. This is 0, 0, 0, 1, 1, 0, 1, 1. So now A, let's say first start with 0, 0 and 0, 0. As both of them are 0, 0, then it is going to be a tie. There is only one element which is 0, 0. So it's going to be tie. Very simple. No matter what you do, the OR will be same. If A, this is example 1, if A is 0, 0 and 1, 0 and B is 0, 0 and 0, 1. I said this is the array. Then see what can happen. This is player 1 and this is player 2. Tell me who will win if this is the array configuration. If this is the array configuration, will player 1 win or will player 2 win? Here it is going to be a tie. So one thing we know from the previous discussion that player 2 is owning a strategic position. It is owning the last bit. So till P1 it is going to be a tie. Till this point it is going to be a tie. And whatever P2 does will determine the solution. So now what will happen? If P2 swaps, if P2 swaps, then A will be 0, 0, 0, 1, B will be 0, 0, 1, 0. In this case, the XOR of A will be 0, 1, XOR of B will be 1, 0. So who wins here? B XOR is greater than A XOR, so player 2 wins. So P2 wins. If P2 doesn't swap, hello? Huh. 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 अच्छा हम्म हम्म ठीक है ठीक है ठीक है कर देंगे बोल देना उसको कर देंगे ओके so if P doesn't swap then A will be 0 0 1 0 B will be 0 0 0 1 and then XOR of A will be equal to 1 0 XOR of B will be equal to 0 1 and here P1 wins. Now one thing I want you to note here is even if this second bit, even if the second bit was 1, let's say second bit was 1, there won't be any difference to this setup. Player 2 will still win with a swap. Player 1 हाँ, अच्छा, ठीक है, ठीक है, उसको उसका क्यू आर मुझे भेज दो। ओके। So this is P2 will win even if it was 1-1 because P1 will decide this. But if this location, this index, or this bit was 1, this most significant bit was 1, uh, then there is going to be a tie. So it is this problem. If you have guessed, if you have not guessed by now, you should have guessed. This problem boils down to the easy version for problem boils down to the easy version for the most significant bit of XOR of A plus B. That's it. So that's the overall code. It remains exactly similar to the easy version. All you have to do is find out the most significant bit of XOR of AB. That is the deciding bit. And for that deciding bit, find out the last person who has a difference, and that person wins. So that was all the questions I wanted to cover today. We have covered B, C1, and C2. In a future live stream, I'll cover the next question, which is the D question. Thank you.